Sargent with the Alarm Museum.
And I'm Ralph W. Sevinor from the Alarm Museum. Welcome.
And I'm Michael Sherman, and I'm from AES Corporation in Peabody, Massachusetts, and we are the manufacturer of the AES IntelliNet product.
All right, so welcome, Michael. We want to go through the history, but I'd like to start before you got into the alarm business. Tell us about when you were young and what you thoughts of, maybe either a career or what kind of work did you want to get into and what were you doing?
Well, growing up, I always knew I was going to be an engineer. Engineering was something that I always thought about, and I knew I wanted to be. New York also was the place where there was always security. Even growing up when I did, which is a long time ago, the trucks had security, the stores had security. Security was ever present. And I figured, gee, that was an interesting place for me.
And about what time frame?
Well, this probably in the 1950s was when I was in high school. I went to a special high school. I went to Brooklyn Technical High School. Not sure I'd do it again. It was an unbelievable commute to get there from where I live, but I did go there, and I wanted to go to engineering school. Ultimately I wound up at Northeastern University, which is in Boston, Massachusetts. I guess I did.
As a double E or?
Well, originally I started as a double E. Then I realized that I was maybe less interested in being a lab rat. That's what I used to call people that design things all the time, and being more of a businessman. My father had a trucking company. He was a businessman. So I decided that I ultimately went into industrial engineering, which is maybe more mechanical engineering, but it's a combination of a lot of different engineering courses. I had chemical engineering, I had mechanical engineering courses, I had electrical engineering courses, but ultimately I wanted to figure out some way that I could become a businessman out of this. And ultimately I went to work. This was in when I graduated in '68. It was sort of a lousy time. It was a tough time for the country, and I went to work for GE making jet engines, and I realized right away that I really didn't want to work for a big company. I wanted to work for a small company, and so I left GE and I went to work for a company called IMLAC, and IMLAC, I worked for the president, and I did everything that needed to be done to run a small business, and that's what I really, really enjoyed. 1974, I went out and I started AES Corporation.
What does AES stand for?
Well, it's funny. Everybody thinks it's my wife's initials, her name is Ann, but it is not. It used to be American Electronic Services, but one of our first customers was the U.S. government. And the U.S. government would never pronounce our name, would never say American Electronic Services. They immediately called us AES. And so we decided to give in, and we became AES Corporation. So it is not my wife's initials. It is used to be American Electronic Services, actually, but corporation. But AES is what the government made it become. And that's basically where we came to IntelliNet. Also, one of the things I didn't mention, growing up, my father was a radio amateur, my brother was a radio amateur, and I became a radio amateur at about the age of 12. And at 12, everything was radio. Again, as I had maybe mentioned earlier, I was clearly your geek. I was Mr. Technology. I did radio amateur things. I did audio things. I just did anything that had to do with technology. I basically loved it and thought it was a great thing to do.
So you had a love of RF, radio frequencies, so
From the age of 12.
from the age of 12. So you would Morse code, you went for the test?
Oh yeah, did I ever? Yeah, and I still know a little bit of it, but if I was to be tested on Morse
Right.
code, not sure I would pass the test now.
Can you explain about AES and Intelenet, how the two work together, what they mean?
Well, just to give you there's a long story here, but what happened is after I went into business, we almost immediately started to do work for the U.S. government.
In security?
In security.
To transmit packets of...
We were transmitting data. We always said that we were in the alarm and signal industry, and I guess we were. Sometimes the data packets were very short, but that's sort of the beauty of the security industry. You don't have to say a lot to get the message across.
Mm-hmm.
And I love packet radio. I love different kinds of radio transmission criteria. And we had an opportunity to do some work for the U.S. government, and we did. And we did a number of different radio systems for them. I guess they would look like security systems. There would be some kind of sensor, and we would take the output of that sensor, which is almost always, in those days, it was always a closing of a contact or an opening of a contact. And we would take that, and we would transmit the fact that it did open or it did close or it did restore or whatever. And we would transmit that data, and we had a receiver, and it was a proprietary receiver. And we made sure that there was some security in the packet. That is, so it's not just a going on or going off of a transmitter, that there was some data in the packet, and the data in the packet said that it was going on or it was going off. Now, in the old days, back in the way old days, we used to use like DTMF tones. These would be the kind of tones that would be on a touch tone, would be on a telephone. That was actually pretty forward thinking. I'm not exactly sure how I would describe that, but the stuff that we were replacing did not have that level of security on it.
So, and at that time, was there a particular demand for this kind of technology, or was this sort of just unfolding as it was going? You know, how it's interesting to think, because it seemed to go pretty quickly into RF stuff, but technology-wise. But I guess what I'm trying to say is, back then, you know, were there a lot of people going into this? You must have seen, I guess, some demand or requirement for it.
Well, we were always made specialized equipment, always. And so the government, the various agencies would say, I need something that does this.
Okay.
And we would make that, exactly that. And that's basically how the alarm industry wound up with Intelenet. It came out of, it was born in the U.S. government. It was born at, we had an SBIR, which is a Small Business Innovative Research Grant.
Mm-hmm.
I think that's right. It's SBIR. We had one from Hanscom Field, from the U.S. Air Force, and we developed a system for them that would do what they want. And it had certain criteria. And the criteria was that it had to be installed by non-technical people. I mean, in theory, you would think that maybe they would have some technical people, but that was one of the criteria.
Yeah, so they told you what they wanted, and then you created it.
Yeah, yes, we made it.
Wow, okay.
Yeah, and we had a whole flock of engineers. Well, maybe at that time, maybe it wasn't a whole flock, maybe it was a small flock of engineers, and they would put together whatever. And to a certain extent, we still do that now. I mean, if you look at AES Corporation, there is a part of the company that is government only, and there's a part of the company which is the alarm industry. And they coexist basically in the same building at the same time.
Did you seek the alarm industry, or did the alarm industry seek you?
Well, I would probably say that I was the one that would seek out the alarm industry. The reality is that we did all this work for the U.S. government, and I looked at it when it was all done, and I said, "Gee, this is great, but maybe this is way more. Is there another application for this?" And that's where the Intellinet.
And about what time frame?
That was done in about 1992, 93. We learned a little bit about the industry at that time, and we got, I think, our first UL listing about 95. That changed things a lot for us. We then did it again at around 2000, and that's probably the listing that we is most of our stuff is listed to.
So that allowed it to become more mainstream.
Well, basically,
accepted.
the alarm industry had been fooling around with radio reporting for years and years before we ever got there. They had, I think the one that was popular when we got there was Safecom Census, Census Safecom, something
Repco,
like that.
I think was another one.
Yeah, Repco was before we ever got there, and there was another one that was done on the CB bands. There was Cardinal, which was a one-way system. There was a whole bunch of other systems, but they were very difficult to install, and they required repeaters, and they just required a lot of gadgets with them. And the alarm industry, some people thought they were great, and some people thought they were awful. One of the things that was unique about our product is anybody could install it. And if you didn't need any kind of central equipment. All you needed was basically every subscriber became a repeater for every other subscriber.
Right.
Which means, so if you had something in the middle, or something that was high up, or I remember some of our first installations were in sort of a mountainous area in Connecticut, New York, and you got a couple of houses that were on a hill. Boom, done. We were done. You didn't have, and we made it very simple for people to install. There was a light. When the light went out, you were in. You were done. There was no field strength. You didn't have to worry about whether or not you could see in a repeater, or you didn't have to pay to be on top of a repeater site. Wherever you were, if the light went out, you're in. You're done, and the unit was installed. So we looked at we looked at the product, and we said, "Gee, this is a lot of really great things. Where else could we sell this?" And it's true. We still sell this product to the U.S. government, but the reality is we probably sell 30 times more to the alarm industry than we do the U.S. government. So it was a good decision. It was a really good decision to take a look at this and say, who else could use this product? And to a certain extent, we're doing that now. I mean, the alarm industry is changing and morphing, and we know that. We're monitoring things that we never thought about monitoring in the past.
Give me some examples.
Well, one of the things that the alarm industry seems to be getting into now is what I consider is industrial kinds of things, where they monitor sewage lift stations. They're monitoring water flow, water tanks. They're monitoring the absence or presence of something, of a heat. I mean, one of the things we always did, but we always didn't do a lot of it, was chicken coops. I didn't realize that. No one knows that chickens have they can only live within a certain temperature range.
Tight tolerance.
And when they go outside of that tolerance, they die. And so we had a lot of, we were monitoring a lot of chicken coops, a lot of temperatures, over temperature sensors in chicken coops. And so we started doing all this kind of stuff, and it was interesting. And then gas wells, oil wells, too much pressure, too little pressure, and we're doing more and more of that every day. Things are becoming much more mechanized. I mean, just there's many more things to monitor now than there was in the past.
Right.
And we are basically adapting our inputs to allow us to hook directly into these sensors and to determine. One of the things that we did way back when, and we're starting to see it here in the US, is fire pumps. Basically in the Middle East, they don't have towers. Like in New York, one of the reasons why you have all these great tanks on the roofs is for the water pressure for the fire systems.
Sure.
Well, they have fire pumps and they have generators, and they have all this mechanisms in order to fight fire.
Right.
But all of that has to be somehow monitored and protected, because you have to know whether the generator is going to generate. Because the fire pumps depend upon the generator being there if the if the power isn't there. And you have to know that the fire pumps, when they turn on, will put out a certain amount of pressure into the fire system. So now we're monitoring that, and we've always monitored that. But now we just see it's more and more of it. And it seems to be the way, maybe the way the industry is going, industry in general is going, and the alarm industry in particular needs to monitor that, because it's important to know whether or not you can put a fire out.
Sure.
It's important to know whether or not, when that pump starts up, that you have like 100 pounds per square inch of water pressure on that head, because if you don't, you're not going to put the fire out.
Right. Or you don't have water for the building.
That's a whole different.
Or your water level in tanks.
Right.
So
Yeah, so you don't see modern buildings with water tanks on the top anymore. That's the thing I grew up with in New York City.
Right.
Yeah.
That's it's interesting.
Those wooden tanks.
Those old big wooden tanks that require a lot of service, a lot of maintenance, and you can't live without them, because there's no other way of putting of charging your fire system without the weight of the water in those tanks. So basically, we're going back to Northeastern, and one of the things that I convinced myself, and I think every time has proven me correct. I thought that engineers, when I went through engineering school, I was an engineer. All I did was do engineering kinds of things, and never did a business thing. I wouldn't know a debit from a credit. I mean, it was awful. I went into business, and I probably made every mistake that you could possibly make. And the reason that I made the mistakes is I didn't know any better.
Right.
Because nobody gave me an opportunity to attend a class that basically told me anything about accounting. And accounting is really important. I mean, a lot of people may consider it boring, but nevertheless, you got to know when the money's coming in, and you got to know where the money is going out. If you don't know that, then you really can't run a business.
Yeah.
So basically, what I did is I started something called the Sherman Center at Northeastern. And it's the Sherman Center for Engineering Entrepreneurial Education. So it's E-cubed or whatever. But I started a center there, and basically the whole concept was to make the engineers or avail to the engineering population. That was the concept of it. Kind of practical business courses. So we have something called REV. REV is, that's called a mentor program where we would hire mentors. Certainly, if you'd like to be a mentor, we certainly could arrange that. You don't necessarily
I'm still making the mistakes.
Yeah, but that's okay. But you've learned a lot in the time being. So we have that. We have something called Generate, and that's where we make products for companies come or graduate students or undergrads will come to us and say, I would like to market this product, but I think this is a good product, but I don't know how to make it. I don't know how to do it. And Generate would do that. We also have a co-op program now, which we're very, very, very proud of, which allows, a lot of, Northeastern has always been the kind of school where kids would go to it because of the co-op program. The income that came from the co-op program was what basically allowed me to go to I was from New York, and here I was in Boston. So it allowed me that the income from the co-op program allowed me to do those kinds of things. And so what we do is we pay co-op, we pay a student now a regular co-op wage so that they work on their business, and they have 6 months to basically make their business a business, I guess. And of the 12 to 14 people that we've processed through the co-op program, all of them but one have actually graduated and gone into the business that they started. So one, it's a very selective criteria, but two, I guess they were very dedicated.
Yeah. Do you has there been someone who has the skills and as far as engineering, but doesn't know what kind of business they want to go into? Is there a direction for that?
Well, I mean, there's always the mentor program. There's the Rev program, which would allow them to speak with somebody. Let's say they wanted to go into the electronic security business, then we would tie them up with somebody like you. I'm a mentor, and they can talk to you about the electronic security business. So, yes, we do that, but the majority of students that we see, and we're open to undergrads, grad students, faculty, as well as, I guess, alumni, prior grads. And but generally speaking, the Sherman Center handles basically the undergrads. What we find is that the undergrads, like me, when I went to Northeastern, I mean, I thought I knew exactly what I wanted to do. I mean, I was a geek before my time, and I knew what I wanted to do. I knew I wanted to be in business. I thought I wanted to be in the security business. Wasn't really sure, but it turned out that through a bunch of, I guess, either good planning or maybe luck, I wound up in the security business, and I think that was a good idea, wasn't it? Being in the security business, yeah.
Can I ask you to put your AES hat on for a moment? And here we are, mid-2022, and the component shortages are in the electronic security business. It's devastating.
Yeah, it's killing us. Yeah,
smoke detectors, controls, cameras, whatever. And I'm sure that's affected you significantly.
Yeah.
Maybe you can talk a little about when we're going to be out of this, how it's affected you. Look in your crystal ball.
Crystal ball. Well, when we're going to be out of this, it's interesting. I think it's going to be a couple of years before we're really out of it. What's happening is everything that we make has a microprocessor. Everything has a microprocessor. I think I mean, you even find them in vacuums now. I mean, you find them everywhere. And I think that's sort of part of the problem. The problem is that a lot of times you can find it, but we had one microprocessor that we used to pay $3.50 for. It now costs us $35. And we have no choice.
Are you able to get supplies?
Yeah, we can. At $35, you can. You'd be surprised at where these things show up.
Yeah.
You'd absolutely. But we have never not produced. If somebody has ordered something, I mean, we have a meeting every morning, and that's probably one of the topics every single morning. Is we discuss this, and we can only take that kind of hit so many times before we can't take it anymore. But we think things are getting better.
You do see inklings of.
Oh yeah, things are getting better.
That's good to hear.
Yeah, things are getting better. What I don't see getting better, I see maybe the top end getting better. We buy microprocessors that are very capable, and they're not particularly cheap to begin with. But like smoke detectors and little wireless sensors, they use like $1.30, $1.50 kind of microprocessors. I see those maybe being the last to come out.
Recover.
Yeah, because there's just less money in it. I mean, if just think about it. If you're a businessman, do you want to sell $8, $10, $12 product, or do you want to sell $1.30 product?
Mm-hmm.
And if it takes you the same time to basically do it and ramp up to do it, then you're better off selling the $12 product.
So, Mike, a question for you. Right now, it's a peer-to-peer network, or it goes from transceiver to transceiver. With the IoT coming out, do you see us from that transmitter talking right to like 5G or 6G, and we don't need that network? Or how do you see that rolling out? IoT in general, and
or is that even a threat?
Well, to a certain extent, IoT is IoT are sensors, and so the question is how do we interface to the sensor? Typically, the way an Intellinet system works is it goes back to so all the units go back. They get whether it's repeated or talking directly to what we call an IP link, which converts the information from the radio domain into the digital domain. So where we do that is basically up to us, and we do have the ability to take devices directly into our radios. We can do that. Typically, we needed a different receiver because IoT signals are usually very short range, and they're usually done at a lot of the public bands, the 900 megahertz band or the 2.4 gigahertz band. And so we have a separate receiver to do that. So we can do it. The question is how do we have to put security on here. We have to make sure that nobody's going to spoof what we do. So when we get the information in from the IoT, we have to, one, know it's real. Two, we also have to packet it in a way so that nobody could mutate it or change it. And then we put it through our system because our system has a whole bunch of different levels of security built into it. So we just want to make sure that's what happens. And so to a certain extent, we do that now. We've just come out with a unit that's called a hybrid. It looks a little bit like our IP link, but it also has a Wi-Fi built into it. So it allows us to receive things that are Wi-Fi, and it also allows us to transmit via Wi-Fi.
So another path.
So we have another a redundant path, but we also have the ability to accept things that are Wi-Fi oriented. There are a number of sensors right now that are Wi-Fi sensors. I have a couple of them on my desk that are water detection sensors. So
That you've interfaced directly.
Yeah, we can interface directly to these sensors. It's just a matter of bringing the stuff in. We look like a Wi-Fi hub, and we bring the data in, and we can send it out. The alarm messages. One of the beauty of the alarm industry still uses something called contact ID, and contact ID is all of 16 bytes long. I mean, it's
Nothing.
It's nothing. In the wonderful world of technology that we're in, the wonderful world of IT that we're in, 16 bytes is not even a header for most of the stuff that we wind up sending. So it's very easy to send this 16 bytes somewhere, anywhere we want it to go. And so that's what we do.
Look into your crystal ball. Where do you see the electronic security industry? And I'm glad you talked about that we're really not in the burglar or fire alarm business. We're in the emergency notification business.
We're in the monitoring business.
We could take any type of emergency signal, a critical event, it doesn't matter what, and we can handle that and process that.
But you know what, Ralph? It doesn't necessarily have to be an emergency signal. That's one of the things. I keep on calling it monitoring. And monitoring is not, a monitoring signal is a signal that somebody wants to know, but it doesn't necessarily predispose an emergency. Now, an event could become an emergency at a later time, but not necessarily at the time. For instance, the fact that you don't have enough water in the tank isn't really a problem until you have a fire. That's an emergency.
Right.
So the fact that you want to know something, it's because you want to know something because it's something that you need to do about it.
Could be.
Right. That it could become a lot more important later on, but in the interim, it needs some sort of attention. And we see this again with typically oil and gas wells and oil tanks. One of the things that I'm learning about is you see all these pumps, these things that look like look like hammers going up and back.
Yeah.
You see pictures of the pumps. Well, most of them are pumping oil. They're marginal producers. They pump marginal amounts of oil into a tank. Well, when that tank fills up, that oil has to go somewhere. So you got to make sure that and they have trucks that come out and they empty these tanks. And you have to make sure that these tanks are empty. And so it's not a catastrophe until the tanks overflow.
Mm-hmm.
Then it's a catastrophe.
Sure.
So that's where your emergency comes in. So a lot of what we're doing now is we still do a huge amount for the security industry. Fire is probably one of our biggest fire alarm system will be tied into an Intellinet radio. It was funny. We were at one of the malls here, and there's all the fire alarm equipment on the wall, and there's the AES Intellinet radio right next to it. I said, gee, that really feels good. I like that.
Yeah.
I like that. And so because when we send an alarm signal via radio,
Mm-hmm.
it's the time that it's registered in the central station is probably a second or two later. As opposed to all of the technology, which is, maybe 45 seconds, maybe 30 seconds.
And in fire, speed is of the essence.
A fire, they say that, what is it, every 90 seconds a fire doubles in size?
I think a little more, but yeah.
Yeah. So you want to get there really, really, really quick, or as quick as you possibly can. So it was, so monitoring information that you want to know, and I'm just trying to think of the right word here. Monitoring information, or critical information, is sort of where I think the alarm industry needs to go. Because unfortunately, a lot of the what the industry used to do is sort of being taken over by the likes of Ring and some of the do-it-yourself kinds of things. And maybe they were never the security industry's customers to begin with. And I've heard that argument many times, that the security industry has only monitored about 20% of the available homes. And that's been pretty steady over the years. So maybe this other group of people that have alarms by somebody else other than the security industry, perhaps maybe they're taking the other 80% of apartments, homes that never would have been professionally monitored in the past. And maybe not. I mean, that's an argument that you can take both sides of and probably win.
You bring an interesting segment in because we've been talking for quite a while about burglar alarms, fire alarms, but something, and we may chuckle about the chicken that you were talking about, but to the chicken owner,
chicken farmer, that's very important
farmer,
stuff.
It's extremely critical, right?
Very important.
It's life and death. I mean, it's business losing.
Well, he has a huge investment, not only in the chickens, but in the eggs that they produce.
Right, so lobster tanks, we talk about the simple ones, like, for example, the tank on the roof, but any type of industry has or many have unique needs to monitor critical events 24/7.
And I think the industry has done not a wonderful job at selling their ability to monitor these things and tell them, gee, you're running out of oil. I mean, this was one of the eye openers that I had received. We had, at one point in time, we were selling a vehicle tracking system, and the most important part of that system was the fact that we would tell them when they were running out of oil in the engine. And I'm saying, what? They don't check it every morning? Nobody checks the oil in the engine. So we would provide these little sensors, the switch sensors, and one of the zones that they would pick up was over temperature, no oil pressure. I forgot, there was like 4 of them. I'm not exactly sure what they were, but I mean, it's incredible to me that these people were driving trucks and cars and police cars, and no one had any idea whether or not there was any oil in the engine.
Yeah.
And I'm saying, gee,
so you were taking that telematics back, real time.
As soon as the thing would flip and say we don't have any oil pressure, or it's too hot, or the water temperature is too hot, we would immediately send it back, and they would get them on the radio, or try to find the truck, or try to find the bus, or whatever.
There's that wireless technology.
There it is. Yeah, I was going to say, you could run, but you can't hide.
Yes.
One of the, you can equate it also to even cyber. And I hear the argument, well, you can send a text to your phone or an email, but people aren't there, right? They're on a plane, they're sleeping, they're in the shower. Coming to a professional monitoring center, we're going to make sure we get the right person at the right time, on time.
Well, it's a matter of how much do you really think about that data? How much do you really need that data? I got to tell you, when a farmer that has 10,000 hens in a metal building in the middle of Kansas, they need to know if they have a problem.
Right.
They need to know right away. And typically what they do is they have fans, or they have other fans, and they can usually, but if it happens at 3 o'clock in the morning, which is maybe unusual because the sun isn't out, but 3 o'clock in the afternoon, and they're out doing something else, tending a field, they need to know that. They need to know it right away, because I guess poultry does not have a really good tolerance for heat.
You triggered something back in my mind in the 1970s, and my central station, which was completely manual. We began to dabble in this thing that we called industrial monitoring. And I don't think, I know at that time, we didn't quite understand the value and how important it was. You know, we monitored water levels in fire tanks, but we did some things with a company that they were hooked up to shaker tables. And we would get a shaker table alarm, and to us, it wasn't a fire, it wasn't a burglar, it wasn't a holdup. So it didn't seem like a big priority. Well, I remember when we got the shock that the company told us, you didn't call us right away, we lost $20,000 worth of product.
What is a shaker table?
It is in a place that is shaking either a drug or some type of chemical or something. They're big tables with lots of
Holes.
vials in them, and they have to be shaken constantly. They also have to, of course, have thermostatic control and that type of stuff. And I just remember the first time, well, we're going to monitor a shaker table. Oh, okay. And the shaker table stopped. So we have to just tell the customer. But there was no sense of urgency for us. This is a long time ago. But you know, you clarify how all of this is such urgently needed to be told immediately.
Well,
Radio, you can do that.
well, we could actually, because of the way our radio works and the fact that everything is repeated for everything else, we could actually go very short distances in very bad environments.
Mm-hmm.
A lot of refineries, oil refineries, use our equipment because they don't have to run wires. And running wires in the oil refinery is a real big problem.
Oh, yeah.
It's very expensive. You can do it. I mean, if you have money, you can do anything, I guess.
Yeah.
But so we have these sensors, and basically around like the perimeters, a lot of it are on the, like near the fences and stuff, and we send our signals right through the refinery,
Mm-hmm.
so that they know what's going on.
Yeah.
If they want you to monitor it, it probably has a monetary effect to them if something goes bad. I'm thinking of shaker tables. That's one of the things that we did years ago with the military. They shake things so that, and who was it? I think UL has one of the tests that they do is they hit the back of our equipment with a ball. They drop it from 3 feet.
To see if it's gonna.
To see if the stuff's gonna blow out the front end or something like that.
Mm-hmm.
And it's I think it has to do with the ability of the equipment to withstand some sort of strike and not hurt somebody with flying debris. And so that's one of the reasons why we still maintain the metal cases.
Mm-hmm.
As much as we sort of don't like the metal cases, and the alarm industry doesn't really love the metal case.
There's a reason for it.
There is a reason for it, and one of them happens to be UL. The fact is, if you hit that case, you can crush it. We've had trucks run over our boxes and crush the boxes, and the equipment still works.
Yeah.
And so, you know, it's kind of a double-edged sword. We don't really know how to get away from it, because if we go to a plastic box or a fiberglass box, I mean, it's not going to withstand that hammer test.
Where do you see the future with
The alarm industry?
and what you're doing? Yeah.
Well, the alarm industry is going to have
Yeah,
to.
the alarm industry, but we'd like to see the expanded version, of all of what you're doing too.
Well, to a certain extent, we're doing it now. A lot of our equipment is on the internet now. A lot of the receivers. The alarm industry is going to like a cloud-based structure, where instead of having rooms full of computers, they're now kind of delegating a lot of that to Amazon Web Services or some other warehouse, and that's what we're doing too. So our receiver now, we just announced it at the ISC show. Our receiver, we basically other than the subscriber hardware, the stuff that you might have sitting in somebody's factory or somebody's office or home, basically everything is become web-based. And so our receivers are web-based because a lot of the software is now web-based. And so we're heading in that direction. We've announced a product line, and so now we're sort of fully web-oriented. And in terms of receiving signals, we're having front ends on all our equipment that are more capable. We've always been able to handle RS-232, which has become sort of an unused format. A format nevertheless, but an unused format. Some stuff use it, and we're going with
TCP/IP.
yeah, TCP/IP, was it Modcom? A lot of industrial pumps and I think it's called Modcom. And it's a format that's basically used for like metal detectors and industrial equipment. Mm-hmm. And we're able to take the information directly.
Right.
So now we could actually send the fact that a water tank is too high or too low, maybe that's not enough data.
So
We can now send it's too high and too low, but it has 555 gallons in it or something like that. So we can actually start providing more information. And that's really where we're going to go is again, professional monitoring, but the people want to know more information. They want to know more about what is going on, because I mean, is it a big problem or is it a little problem? Mm-hmm. For instance, again, not to go back all the time to chickens, but if you're 10 degrees hotter than you're supposed to be, then maybe that's a really big problem. And quite frankly, I really don't know. Mm-hmm. If you're 1 degree, maybe it's not such a big problem. Maybe you can finish doing what you were doing and then go back and turn the other fan on. Mm-hmm. So having the fact that you're over temperature, yes, you want to know. But all right, how bad a problem do you have? I mean, do you have a serious problem, or a serious problem in the making, mm-hmm. or maybe a less than serious problem? It's nice to know. It's nice. You have to do something about it, but not necessarily that instant.
Yeah.
And we see a lot of that, and I think that's what's going to happen. I mean, one of the beauties of working with Northeastern, and because they have a lot of different programs, and I mean they're burying IoT sensors into bridges, into concrete
for stress.
So to see whether or not it's getting it's stressed, or the rebars are rusting out, and they're doing all kinds of stuff.
Yeah, that's great.
And they're using what do you call it? The motion of the bridge to generate enough energy to transmit.
Piezo.
Yeah, to transmit out. But I mean, the range is 100, maybe 100 meters.
That's amazing.
If that. So they're doing a lot of things, but we just have to figure out what the industry, and we kind of hope the industry will tell us that, what the alarm industry will say to us in terms of what they want, in terms of what they want to monitor. Because, I mean, some dealers have a lot of oil wells and chicken coops. Right. And some dealers, I would imagine, in New England, you have very few oil wells and chicken coops.
But it's almost where your imagination takes it, right?
Yeah.
You have to...
Sure, but at the same point in time, you want to be useful. Yeah. You want to be able to...
figure out the needs.
Right. Like one of the things we've been fooling around with is, we do a lot of, is water monitoring. Didn't realize it, but most of the buildings in DC area have asbestos in them. And so everything is sealed. You can't get into a wall there. Because if you do, it becomes an asbestos catastrophe. So if there's a water leak or something, you gotta know it. And you don't know it until a lot of damage has been done. And when the damage has been done, it's all this asbestos, which just amplifies it just tremendously. I mean, so, you know, so we're starting to think about that.
Yeah.
I mean, so this is not something that we would know about. This is something a dealer would bring to us.
Right.
We don't know about these things. How do I know that the halls of Congress are loaded with asbestos? Well, I know that.
Yeah. Ralph, you got anything?
This was fantastic. You know, as you were speaking, I was thinking of more and more applications, and your mind starts to go wild. So
The whole idea is we are always looking for applications.
Yeah.
Love to talk to anybody that will talk to me about applications. The biggest problem is that and I found this originally when we first went into the alarm industry. We got into some dealers, and you probably know who they are, that had some very strong feelings about what we should be doing and how we should be doing it. As it turns out, they had a unique set of circumstances that was theirs and theirs only. So we wound up doing an output that emulated a certain receiver, and as it turns out, that wasn't the receiver that everybody used. So then we had to go and change it all.
Sure.
And that cost us a lot of money and a lot of time. And time is maybe more important than money. Is because, you know, money is capital, but time is market opportunity. And that's really what we want to get to, market opportunity.
This is fantastic. This is what a great opportunity. Thanks for all your contributions to the industry.
Oh, it's been a pleasure.
Yeah.
Actually, I love the alarm industry. I've always have. I remember, I think my father's trucks used to have alarms in them. Oh, one of them had an alarm in it.
Babco or something.
Babco, yeah. I think it was a Babco. I mean, and it was such a crude device. But I mean, it worked.
Right.
Yeah.
It worked, and to a certain extent, the old dropping relays and stuff. I mean,
They're still out there, I might
They
add.
are.
Yeah.
Sure.
I mean, they are they're good. I mean, and they work. And there's so much other than the fact they're not really high tech, but they perform the function that you want.
Yeah.
If you want to scare the perpetrator away and ring a bell and
Simple.
you can do that.
Michael, it's a pleasure.
My
Thank you
pleasure.
so much.
Well, thank you so much for inviting me.
Thank you so much.
Yes,
Great having you.
yeah, it was. This is a lot of fun, and certainly for everyone out there in the security industry, I certainly hope you have a little better idea of the future. And this is one person's idea of where I think the industry should go.
Excellent.
All right.
Thank you so much.
Well, thank you.
Okay.